Picture this. It's 2023, and a scientist named Wang Jiehu is staring at his computer screen in disbelief. The numbers can't be right. He's been analyzing DNA from 3,154 people across the planet, from Africa to Asia, Europe to the Americas. And what he's seeing is impossible. According to his calculations, 900,000 years ago, the entire human population crashed to just 1,280 breeding individuals. Not 1.28 million, not 128,000, just 1,280 people capable of having children. That's smaller than most high schools. For context, there are more giant pandas alive today than there were humans back then. We came closer to extinction than the world's most endangered species. Who double checks, triple checks? He runs the analysis again using a revolutionary new method called fit coal. Every time the same terrifying result appears. For 117,000 years, longer than our species has even existed. Our ancestors survived with numbers so low that mathematically we shouldn't be here. The scientific world erupted when the findings hit the journal Science on August 31st. Some called it impossible. Others said it explained everything. Why humans have such weirdly low genetic diversity. Why we're all so similar despite living across the globe. Why chimpanzees in one forest have more genetic variation than all 8 billion humans combined. Think about that. Every person you've ever met, every human who ever lived, descended from a group you could fit in a large movie theater. Your ancestors, my ancestors, everyone's ancestors. They were all there, huddled together against a world trying to kill them. The research team, led by Chinese scientists at the Chinese Academy of Sciences, had cracked a code hidden in our DNA. Using mathematical models that trace genetic changes backward through time like a molecular time machine, they could see the moment humanity almost ended. But here's what makes your spine tingle. This wasn't a quick disaster like an asteroid or volcano. This lasted 117,000 years. That's 4,000 generations of humans living on the edge of extinction. Every birth was a miracle. Every death could have ended our species. And during this impossible time, something extraordinary happened. 2 of our chromosomes fused together. It's why you have 46 chromosomes while chimps have 48. This genetic accident, happening when we were nearly extinct, would later separate us from every other ape forever. The discovery explains the mysterious gap in the fossil record. Archaeologists always wondered why human fossils almost disappear between 950,000 and 650,000 years ago. Now we know. There simply weren't enough humans to leave fossils. With only 1,280 people scattered across Africa, finding their bones would be like finding a specific grain of sand on a beach. This discovery isn't just about the past. It's about understanding how close we came to never existing, because 1,280 people refused to give up. The world was dying, and it was taking us with it. 930,000 years ago, Earth's climate didn't just change, it broke. Scientists call it the mid-Pleistocene transition, but that's like calling a hurricane weather. This was planetary warfare against life itself. For millions of years, ice ages had come and gone in predictable 41,000-year cycles, like a metronome. Cold, warm, cold, warm. Our ancestors could adapt. Then suddenly the rhythm changed. Ice ages stretched to 100,000 years. The cold periods became colder. The ice sheets grew until they covered a third of the planet. Imagine waking up one day and winter just never ends. That's what our ancestors faced, except it wasn't one day. It was generations watching the world freeze. In Africa, Where humans evolved, the disaster was different but equally deadly. The continent didn't freeze, it dried up. Rainfall dropped by half. The Sahara, already a desert, expanded until it swallowed entire regions that had been grasslands. Lakes that had existed for millions of years evaporated. Rivers that never stopped flowing became dusty channels. The Kalahari Desert expanded northward by 500 miles. The rainforests of Central Africa shrank to tiny pockets. Places that had supported hundreds of species now couldn't support a dozen. It wasn't just climate change, it was climate annihilation. Dr. Chris Stringer from London's Natural History Museum puts it bluntly. This wasn't adaptation weather. This was extinction weather. The numbers are staggering. Global temperatures dropped 11 degrees Celsius below today's levels. Sea levels fell by 400 feet as water locked into continent-sized ice sheets. The Mediterranean Sea partially dried up. You could walk from Africa to Europe. But the worst part wasn't the cold or the drought. It was the unpredictability. One decade might see slight warming, giving hope. The next would be the coldest in 1,000 years. Plants and animals couldn't adapt to conditions that changed faster than evolution could follow. Food sources disappeared. The large mammals humans hunted went extinct or migrated to unreachable places. Plants that provided reliable nutrition died off or became so rare that finding them was like winning a lottery. The fruits and nuts that supplemented meat diets vanished. Even insects, that last resort protein source, became scarce. Archaeological evidence from this period is heartbreaking. Sites that had been occupied for thousands of years were suddenly abandoned. Tools left mid-production as if their makers had to flee immediately. Hearths that had burned for generations went cold and were never relit. The fossil record shows mass extinctions across Africa. Antelope species that had thrived for millions of years disappeared. Predators that had dominated ecosystems vanished. The entire food web collapsed, and humans were caught in the collapse. This wasn't just a crisis, it was the closest life on Earth had come to a complete reset since the age of dinosaurs. And humans, still a young species barely different from apes, were completely unprepared. The planet had supported our ancestors for over 1 million years. Now it seemed determined to erase us. Count to 1,280. Go ahead, I'll wait. That's every human ancestor who survived. Every single person whose genes made it through the bottleneck. If you're reading this, your great-great-great. Add about 30,000 more greats. Grandparents were among them. But who were these 1,280 survivors? Where did they live? How did they avoid the fate that killed 98.7% of their species? The math is crucial here. Scientists don't mean 1,280 total humans. They mean 1,280 breeding adults. Add in children, elderly, and those unable to reproduce. And the total population was probably around 2,000 to 3,000 individuals. That's still terrifyingly small. Modern conservation biologists consider any species with fewer than 5,000 individuals to be critically endangered. These survivors weren't in one place. Genetic evidence suggests they were scattered across Africa in perhaps 25 to 60 small groups. Each band contained maybe 20 to 50 people. Extended families, basically. Imagine your family reunion, except it's everyone you'll ever know, and if they die, your species ends. Dr. Chris Stringer from the Natural History Museum explains, they couldn't all be in one location. One drought, one disease, one predator attack could have ended humanity. They had to be spread out, but not so far they couldn't find each other for mating. The genetic diversity patterns tell us something fascinating. These weren't random survivors. They were likely concentrated in refugia, special locations that maintained livable conditions while the rest of Africa turned hostile. Think of them as lifeboats in a sinking world. Southern Africa's coast emerges as the most likely sanctuary. Here, the cold Benguela Current created a unique microclimate. While the interior turned to desert, the coast had reliable rainfall. The ocean provided food when land animals disappeared. Shellfish, fish, seabirds, and marine mammals offered protein. Kelp forests provided nutrients. Tidal pools gave easy gathering opportunities. Professor Curtis Marion, who studies this period, calls it the aquatic ape hypothesis without the ape. Humans didn't evolve in water, but water saved us from extinction. The survivors were probably Homo heidelbergensis, or a transitional species heading toward Homo sapiens. They stood about 5 feet 9 inches tall, with brains about 75% the size of ours. Not quite human, not quite ape, but smart enough to innovate when innovation meant survival. These weren't the strongest individuals or the fastest or even the smartest. They were the luckiest, lucky enough to be in the right places when everywhere else became wrong. But they were also the most cooperative. In groups this small, one selfish individual could doom everyone. Only those who shared, who helped, who put group survival above personal gain, made it through. The genetic evidence shows something else remarkable. These 1,280 people maintained genetic diversity better than they should have. This suggests they had sophisticated mating networks, carefully avoiding inbreeding despite the tiny population. They knew who was related to whom, probably across multiple bands, and made mating decisions that preserved genetic health. These 1,280 weren't just survivors. They were genetic geniuses, ecological masters, and social coordinators playing three-dimensional chess with extinction. Close your eyes. You're one of the 1,280 walking through what's left of the African woodland. Every shadow could hide death. Every sound might be your last. Because the world of 900,000 years ago wasn't just climatically hostile. It was filled with monsters that considered humans a light snack. The saber-toothed cats were the worst. Homotherium, the scimitar cat, weighed 400 pounds and could run 60 miles per hour. Its 7-inch canine teeth were literally designed to puncture primate skulls. It hunted in groups. It was smart, and it had been perfecting the art of killing humans for millions of years. Dr. Alan Turner, who studies prehistoric predators, doesn't mince words. Humans were not apex predators. We were prey, preferred prey. The cats hunted at dawn and dusk, exactly when humans needed to gather water. They could leap 12 feet vertically. They cached kills in trees where humans couldn't reach. Most terrifyingly, they seemed to understand human behavior patterns. Fossil evidence shows they waited near regular human paths, near water sources, near shelters. But saber-tooths were just the beginning. Cave lions, 25% larger than modern lions, ruled the night. No mane to grab, no roar to warn you. They killed in silence. One specimen from this period measured 11 feet long without the tail. Its bite force could crack a human skull like an egg. Then there were the hyenas, not the smaller scavengers we know today, but Pachacrocuta, the giant hyena, 5 feet tall at the shoulder with bone-crushing jaws that could splinter a mammoth femur. They hunted in packs of 20 or more. They were persistent, following human groups for days, waiting for someone to fall behind. The archaeological record from this period is a horror show. Human bones with tooth marks, skulls with puncture wounds matching saber-tooth spacing, child remains in hyena dens. We weren't winning these encounters. Dr. Lee Berger, paleoanthropologist, found evidence at sites in South Africa. Humans were being processed like any other prey animal. Bones cracked for marrow, skulls opened for brains. We were part of the food chain, not on top of it. The short-faced bear, Agriotherium, added another dimension of terror. Imagine a grizzly bear, but 30% larger, faster than a horse, and able to stand 11 feet tall. They were omnivores, but with humans so protein-starved and small, we were definitely on the menu. Even the herbivores were deadly. The last of the giant geladas, baboons the size of gorillas, competed for the same plant foods humans needed. They had 4-inch canines and moved in troops of 100 or more. Get between them and their food source? You became fertilizer. The rivers and lakes had their own monsters. Crocodiles twice the size of modern ones, perfectly camouflaged, patient as stone. Every drink of water was Russian roulette. But here's what's remarkable. The 1,280 survived all of this. They developed strategies we can barely imagine. They learned to read predator behavior. They created defensive formations. They used fire not just for warmth, but as a weapon, the only one that worked against everything. They turned from prey into something unprecedented, prey that fights back with intelligence instead of strength. Dawn. You're one of the 1,280 and you've survived another night. That's not a given, it's a victory. Now the real work begins. Water first. Always water. In the parched landscape of bottleneck Africa, permanent water sources were maybe 10 miles apart. That's a 20-mile round trip, carrying water in animal bladders or ostrich eggs through territory where everything wants to kill you. Dr. Rick Potts from the Smithsonian reconstructs a typical day. Wake before dawn to avoid predators. Send scouts to check the water source. Are predators waiting? Move in groups, never alone. Carry weapons, carry fire, get water, get out. No lingering. But water was just the beginning. Food required different strategies for different seasons, and all of them were desperate. During the rare good times, there might be carcasses to scavenge, but you're competing with hyenas, vultures, and other humans. You wait for the lions to finish, then the hyenas. Then you dash in to crack bones for marrow, the only part left. Marrow is rich in calories, but getting it means exposing yourself in the open, smashing bones with rocks while predators circle. Plant foods. The climate had killed most reliable sources. The survivors learned to eat things that would horrify us. Grass seeds, painstakingly collected handful by handful. Roots so fibrous they required hours of pounding to be digestible. Bark from certain trees, stripped and boiled if you had water to spare. Dr. Amanda Henry, studying ancient tooth plaque, found evidence of desperation foods. They were eating sedges, cattails, grass seeds, things with so little nutrition you'd need pounds just to survive. They were processing plant toxins their ancestors never touched. Insects became crucial. Termites provided protein and fat. Grasshoppers, when available, were like finding treasure. Ant larvae, beetle grubs, anything with calories. One archaeological site shows evidence of systematic termite harvesting with specialized tools just for breaking into mounds. The coastal survivors had it marginally better. Shellfish provided reliable protein. Low tide meant guaranteed food if you could get there, but coastal meant competing with seals, dealing with tides, and risking being cut off from escape routes. Tool-making wasn't a hobby, it was hourly survival. Your cutting stone breaks, you might not eat today. Your spear point shatters, you're defenseless. The archaeological record shows incredible curation of tools. A single hand axe might be resharpened dozens of times, carried for years, passed between generations. Fire was everything, not just one fire, multiple fires. A main hearth for warmth and cooking. Defensive fires around the camp perimeter. Torch preparations for night movement. smoke signals for other bands. Keeping fires alive during rain meant the difference between eating and starving, between warmth and hypothermia. Dr. John Gowlett, studying ancient hearths, notes, fire management would have consumed hours daily. Gathering fuel, maintaining flames, protecting coals. It was a full-time job that someone's life depended on. Sleep? In shifts, always. Someone watching, someone ready to grab children and run. Shelters were temporary, cave entrances when available, thorn barriers when not. Never too comfortable, never too permanent. Ready to flee at a moment's notice. Every calorie burned had to be justified, no wasted movement, no unnecessary risks. Every decision calculated. Is this worth the energy? Can we afford the danger? This wasn't living, this was surviving, minute by minute, for 117,000 years. In the darkness of near extinction, only one thing stood between the 1,280 and oblivion: fire. Not just any fire, mastered, controlled, weaponized fire that transformed from tool to salvation. Dr. Michael Chazon, studying Wonderwerk Cave in South Africa, found something profound. Around 900,000 years ago, fire use went from occasional to constant. It's like they realized fire wasn't just useful, it was mandatory. The evidence is everywhere in the archaeological record. Hearths that burned continuously for decades, ash layers meters thick, heat-fractured rocks arranged in defensive patterns. This wasn't campfire cooking. This was industrial-level fire management. Consider what fire meant to a group of 30 humans surrounded by darkness and predators. Light that extended usable hours by 40%. Warmth that allowed survival in temperatures that would otherwise kill. Smoke that signaled other human groups across vast distances. But most importantly, fire was the only thing predators universally feared. Professor Catherine MacDonald discovered something remarkable at Kesem Cave in Israel. They weren't just using fire, they were engineering it. Different temperatures for different purposes. Hot fires for warmth, cooler fires for smoking meat, specific temperatures for tool making. The 1,280 had turned fire into technology. They learned that different woods burned differently. Acacia for quick heat, hardwoods for long-burning coals, certain barks that produced insect-repelling smoke, dried dung that burned steady when wood was scarce. But mastering fire during the bottleneck meant solving problems we can barely imagine. How do you keep fire alive during torrential rain with no permanent shelter? How do you transport fire across rivers? How do you maintain flames when every piece of dry wood for miles has been burned? The answer was ingenious. Fire bundles, slow-burning fungi wrapped in green leaves, insulated with ash, could smolder for days. Carried in hollow bones or wrapped in hide, these prehistoric lighters meant never being without fire. One site in Ethiopia shows evidence of fire bundles prepared but never used. Emergency backups for desperate times. Dr. Dennis Sangeether, studying Paleolithic fire use, explains the revolution. They went from using fire to thinking with fire. Every decision involved fire logistics. Where to camp based on fuel availability. When to move based on fire carrying conditions. How to hunt using fire as a weapon. And weapon it was. The 1,280 learned to use fire offensively. Grass fires to drive game. Smoke to flush prey from hiding. Burning barriers to channel predator movement. One site shows evidence of a controlled burn that created a killing field, surrounded by fire except for one exit where humans waited with spears. Fire transformed nutrition. Cooking increased caloric extraction from food by 30 to 50%. Tough roots became edible. Toxic plants became safe. Meat that would spoil in hours could be smoked to last weeks. For a population on the edge of starvation, these extra calories meant survival. But perhaps most importantly, fire created something intangible: hope. Imagine the psychological impact of controlling the one thing that scared away the monsters, the empowerment of creating light in a dark world, the comfort of warmth when everything else was hostile. Dr. Polly Wiesner, studying fireside behavior in modern hunter-gatherers, notes, firelight changes human psychology. Stress hormones drop, social bonding increases, stories get told, culture gets transmitted. Fire didn't just warm bodies, it created the conditions for being human. The 1,280 didn't just tend fires, they worshipped them, protected them, built their entire existence around them. Fire was parent, protector, and providence. When everything else abandoned humanity, fire remained faithful. And perhaps that's why, even today, we're drawn to flames. Deep in our genes, we remember when fire was the only friend we had left. Deep in the nucleus of every cell in your body lies evidence of the moment humanity changed forever. It happened during the bottleneck when we were nearly extinct, and it separated us from every other ape permanently. You have 46 chromosomes. Chimpanzees, our closest relatives, have 48. Gorillas have 48. Orangutans have 48. Somewhere around 900,000 years ago, right when our population crashed, two of our ancestral chromosomes did something extraordinary. They fused. Dr. Ken Miller from Brown University explains it simply. Imagine taking two books and gluing them together to make one longer book. That's what happened. Our chromosome 2 is literally two ape chromosomes stuck together. You can see the fusion point today. It's right there in the middle of chromosome 2. Telltale sequences that should only exist at chromosome ends, sitting in the middle like a scar. The genetic equivalent of finding a zipper in the middle of your shirt. But here's what makes scientists' heads spin. This fusion happened during the bottleneck in a population of just 1,280 people. In that tiny group, someone was born with this massive genetic change. And instead of dying, which is what usually happens with major chromosomal alterations, they thrived. Dr. Evan Eichler, who studies human genome evolution, calls it the luckiest genetic accident in history. Think about the odds. Chromosome fusions are rare, maybe one in millions of births. Most are fatal or cause severe disabilities. But this one, happening in a population already on the brink of extinction, not only survived but spread to every human being who would ever live. The fusion created immediate problems. Anyone with 46 chromosomes trying to mate with someone with 48 would likely have fertility issues. Their children might be sterile, like mules. Yet somehow, in that tiny population, the fusion became universal. Dr. Francis Arnold, studying chromosomal evolution, proposes a startling scenario. The fusion might have initially isolated a small group within the already tiny population. Maybe just one extended family. But if that family had other advantages, better cooperation, better tools, better location, they could have out-survived the others. The fusion wasn't just a neutral change, it altered gene expression in ways we're still discovering. Genes near the fusion point behave differently than they did when on separate chromosomes. Some researchers think this might have affected brain development, contributing to the cognitive leap that defines humanity. The timing is too perfect to be coincidence. Right when humans nearly went extinct, right when we needed every advantage, our chromosomes restructured in a way that would later distinguish us from every other primate. Neanderthals had 46 chromosomes too. So did Denisovans. This means the fusion happened before these species split from our common ancestor in that bottleneck population. Every human species that emerged from the crisis carried this genetic signature. Dr. Mario Ventura, who sequenced the fusion region, found something else remarkable. The fusion region is incredibly stable. In 1,000,000 years, it's barely changed. It's like evolution said, "Don't touch this," and protected it. But the fusion had a dark side. It might have created reproductive isolation, preventing the survivors from breeding with other human populations that didn't go through the bottleneck. This genetic barrier could explain why the bottleneck was so severe. The 1,280 weren't just the only ones left. They were the only ones genetically compatible with each other. Today, that fused chromosome carries genes crucial for brain development, immunity, and reproduction. Every time your cells divide, they carefully replicate that ancient fusion, preserving the moment when humanity became something new. We are all children of a chromosomal accident that should have killed us, but instead made us unique. When you're one of only 1,280 humans capable of having children, every romantic decision could doom or save your species. The dating pool wasn't just small, it was a puddle, and swimming in it were your cousins' cousins, and people whose genetic similarity to you was dangerously high. Dr. Bernard Crespi, who studies human mating systems, puts it bluntly. They had to be incredibly sophisticated about who mated with whom. One generation of careless inbreeding could have ended humanity. The math is terrifying. In a population of 1,280 breeding adults spread across maybe 30 groups, each band of 40 people might have had 5 or 6 potential partners who weren't closely related. But not closely related is relative. Everyone was more related than modern, isolated populations. How did they avoid genetic catastrophe? The answer reveals sophisticated social intelligence we didn't think existed 900,000 years ago. First, they had to know who was related to whom across multiple groups. No written records, no DNA tests, just memory. Oral traditions that tracked lineages, stories that encoded genetic relationships, songs that warned against certain pairings. Imagine keeping a mental family tree for hundreds of people across thousands of square miles. Dr. Laura Fortunato from Oxford, studying kinship systems, discovered something remarkable. Modern hunter-gatherers can track relationships to the 7th degree. The bottleneck survivors probably had similar or better capabilities. Their survival depended on it. The survivors developed what geneticists call sex bias dispersal. When boys reached puberty, they left. Not to the next valley. That's where their cousins lived. They had to travel far, maybe 100 miles or more, to find groups distantly related enough for safe mating. Imagine being 14 in a world where everything wants to kill you, and being sent alone into the wilderness to find a wife you've never met from a group you've only heard about in stories. That wasn't cruel. It was species preservation. But dispersal alone wasn't enough. The groups had to maintain connection networks. Seasonal gatherings where multiple bands would meet. Young people could assess potential partners, and elders could negotiate marriages. These weren't romantic meetings. They were genetic diversity conferences with dancing. Dr. Kim Hill, studying modern foragers, found evidence of what the bottleneck survivors likely practiced. Multi-level societies. Your immediate band was family. Your cluster of bands was your tribe. But you maintained weak ties with distant clusters specifically for mating exchanges. The women had their own strategies. In most primates, females stay with their birth group. But genetic evidence from the bottleneck suggests human females also moved, though less far than males. This bidirectional movement maximized genetic mixing. There's evidence of something even more sophisticated: selective pair bonding. Unlike our ape relatives who mate opportunistically, the bottleneck survivors seem to form long-term pairs, not just for romance, for genetic calculation. Pairing reduced the chance of accidental inbreeding and allowed tracking of offspring parentage. The consequences of mistakes were visible and terrible. Skeletal evidence from this period shows developmental abnormalities consistent with inbreeding, curved spines, asymmetrical skulls, dental problems. These served as warnings, living reminders of what happened when genetic diversity wasn't maintained. Dr. Agustin Fuentes, studying primate mating, notes something profound. The bottleneck might have created human love as we know it, not just mating, but careful partner choice, long-term bonding, and social support for couples. Romance born from the need to avoid extinction. Every love story from the bottleneck was a genetic calculation wrapped in emotion. Every marriage was a treaty between groups. Every child was a dice roll against extinction. And somehow, through careful mate choice, extensive travel, and sophisticated social networks, 1,280 people maintained enough genetic diversity to recover. Love didn't just survive the bottleneck. Love was how we survived it. A child born during the bottleneck had a 50% chance of dying before age 5. The ones who survived grew up in a world where normal meant dancing on the edge of extinction every single day. These weren't childhoods with toys and games and carefree play. These were intensive apprenticeships in not dying. Dr. April Nowell, who studies prehistoric childhood, paints a stark picture. Children of the bottleneck had to grow up fast. By age 5, they were contributing to group survival. By 10, they were semi-autonomous. By 14, they were adults. The archaeological evidence is heartbreaking. Tiny hand axes, perfectly formed but child-sized. Miniature spear points that show practice marks. A child's footprints preserved in mud, following adult tracks exactly. Learning to walk where adults walked because deviation meant death. But what really strikes researchers is what's missing: toys. In archaeological sites from before and after the bottleneck, we find dolls, gaming pieces, miniature animals. During the bottleneck, almost nothing, as if childhood itself was a luxury the species couldn't afford. Dr. Michelle Langley, studying childhood objects, found one exception that breaks your heart: a carved piece of bone, possibly a comfort object, clutched in a child's burial. 3 years old, based on tooth development. The carving worn smooth from handling. Someone loved this child enough to bury them with their favorite thing. Education wasn't formal. It was constant. Wake up, watch, adults, follow, mimic, practice. A 5-year-old learning to recognize predator tracks. A 7-year-old knowing which plants would kill you and which looked identical but would save you. A 10-year-old maintaining fire through the night because if it died, everyone might die. The psychological impact must have been devastating. Modern children who experience severe trauma show specific patterns: hypervigilance, emotional numbing, early maturation. The bottleneck children lived in constant trauma for thousands of generations. Dr. Penny Spickens, studying prehistoric emotions, notes, these children never knew safety, never knew abundance. Their normal was our nightmare. Yet they developed coping mechanisms so effective they're still in our genes. Our anxiety responses, our threat detection, our ability to dissociate from overwhelming fear. But there's evidence of love too. A skeleton from this period shows a child with a deformed leg, unable to walk normally. They lived to age 12. Someone carried this child. Someone fed them when they couldn't gather. Someone protected them when they couldn't run. In a world where every calorie mattered, a group kept a useless child alive for 12 years. Children learned through stories. Without writing, all knowledge was oral. Stories about where water could be found in drought. Stories about which animals attacked and how. Stories encoding 100,000 years of survival knowledge. Miss a detail in the story, that missing detail might kill you next season. The pressure created extraordinary capabilities. Studies of modern hunter-gatherer children show they can navigate by stars by age 8, identify hundreds of plants by age 10, track animals invisible to adult anthropologists. The bottleneck children were probably even more capable. Dr. Alyssa Crittenden, studying forager children, discovered something amazing. These children don't play at being adults. They are adults in training from toddlerhood. Every game teaches survival. Every story encodes crucial information. Every interaction builds the social bonds that will keep them alive. The children who survived the bottleneck were genetic lottery winners and educational prodigies. They mastered skills we struggle to learn as adults. They processed trauma we can't imagine. They carried the entire future of humanity in their small, capable hands. Every child born during those 117,000 years was both a miracle and a gamble. A miracle they existed at all. A gamble they'd survived to have children of their own. Every one of your ancestors survived childhood when childhood itself was barely survivable. In a cave in southern Africa, archaeologists find something that shouldn't exist. A perfectly crafted hand axe from 900,000 years ago, made with such precision it could be mass-produced today. Nearby, another and another. Dozens of identical tools, each one representing hours of work when hours meant calories burned that might not be replaced. These weren't just tools, they were the thin edge between existence and extinction. Dr. Shannon McFerrin, studying these ancient implements, makes a startling observation. During the bottleneck, tool-making didn't just continue, it became obsessively refined. Like their lives depended on every strike of stone on stone, which, of course, they did. The Acheulean hand axe was the Swiss Army knife of the bottleneck, one tool that could skin, cut, dig, scrape, and kill. But making one required extraordinary skill. You had to see the tool inside the raw stone before you started, visualize every strike before making it. One wrong hit and hours of work became worthless rubble. The 1280 didn't have room for error. A broken tool might mean not eating. A poorly made spear point might mean becoming something else's meal. So they developed what archaeologists call hyper-curation, maintaining and resharpening tools far beyond what previous populations did. One hand axe from Ethiopia shows 47 separate resharpening episodes. Someone carried this tool for possibly years, resharpening it each time it dulled, reducing it from the size of a hand to the size of a thumb. When you can't afford to make new tools, you squeeze every possible use from what you have. Dr. Dietrich Stout, studying the neuroscience of toolmaking, discovered something profound. Making these tools required the same brain regions we use for language. The bottleneck may have literally sculpted our brains through stone napping. Every tool made us more human. But the real innovation wasn't in the tools themselves, it was in how they were taught. With such a small population, losing tool-making knowledge would be catastrophic, so they developed teaching methods that seem almost modern. Archaeological evidence shows practice areas, spots where clearly inferior tools were made, mistakes tolerated, learning encouraged. In a world where every resource mattered, they still set aside materials for children to fail with. That's how crucial skill transmission was. They developed specialized tools for the crisis, grinding stones for processing grass seeds, previously ignored but now vital. specialized points for different prey, because you couldn't afford to use mammoth hunting spears on rabbits when there were no mammoths. Composite tools, handles made from one material, cutting edges from another, bound with sinew or plant fiber. Dr. Lynn Wadley, studying hafting technology, found evidence of sophisticated adhesives. They were making glue from tree resin, requiring precise temperature control. Too hot and it burns. Too cool and it won't bond. They were doing chemistry without knowing what chemistry was. The tools tell stories of desperation and genius. Microliths, tiny, sharp fragments that could be hafted in rows to create cutting edges. When you can't find good stone, you make many small tools instead of few large ones. Bone tools become common. When stone is scarce, you use what the dead leave behind. But perhaps the most telling evidence is what archaeologists call expedient tools. Rocks grabbed and used immediately, then discarded. These increase dramatically during the bottleneck. No time for perfect tools when survival is measured in minutes. The toolkit also reveals social cooperation. Some tools required multiple people to make. One holding, one striking, one directing. Toolmaking became communal. Knowledge shared rather than hoarded. In groups of 40, you couldn't afford to have just one toolmaker. Dr. Nicholas Toth, experimental archaeologist, spent years trying to replicate bottleneck-era tools. These weren't primitive people making crude implements, they were engineers working under impossible constraints, creating solutions we're still trying to understand. The southern tip of Africa, 900,000 years ago, while the rest of the continent turned to dust and death, something miraculous was happening here. The ocean was keeping humans alive. Dr. Curtis Marion stands on the cliffs at Pinnacle Point, South Africa, looking at caves that saved our species. This wasn't just a refuge, he says. This was humanity's emergency room, and the ocean was the doctor. The Benguela Current, flowing cold from Antarctica, created a unique microclimate. While inland Africa baked and dried, this coastal strip received regular fog and moisture. Plants that died everywhere else survived here. Animals that went extinct inland found sanctuary by the sea. But the real salvation was in the tidal zones. Twice a day, the ocean delivered a buffet. Shellfish trapped in pools as the tide retreated. Seaweed rich in iodine and minerals. Fish stranded in shallow channels. For the first time in human evolution, our ancestors had a predictable food source. The archaeological evidence is overwhelming. Shell middens, ancient garbage heaps, stretch for miles along the South African coast, layer upon layer, representing thousands of years of continuous occupation. The same caves, the same beaches, the same survival strategy repeated for the entire bottleneck period. Dr. Antonietta Gerardino, studying these middens, found something remarkable. They weren't just eating shellfish randomly. They were managing the resource, taking only certain sizes, avoiding breeding seasons, rotating collection areas. This is systematic marine farming 900,000 years before agriculture. The coast provided more than food. Ochre, the red pigment that would later become humanity's first art supply, was abundant here. Silkrit stone, perfect for tool making when heated, littered the beaches. Caves provided shelter from predators and weather. Fresh water seeped from cliff springs even during the worst droughts. But coastal living required new knowledge. Tides that could trap and drown. Waves that could sweep you away. Marine predators, sharks, killer whales. Seals that were themselves predators. The 1,280 had to become maritime experts without boats. Marine biologists without science. They learned that spring low tides exposed the most shellfish, that certain seaweeds were toxic unless dried, that octopi hiding in pools could be extracted with thorns, that whale strandings, rare but miraculous, could feed a band for months if the meat was properly smoked. Dr. Christopher Henshelwood, excavating at Blombos Cave, found evidence of how sophisticated these coastal survivors became. 75,000-year-old fish bones from deep water species. They were somehow catching fish that don't come near shore. Boats, tidal traps, we don't know, but they were marine harvesting at an expert level. The refugees weren't just in South Africa. Genetic evidence suggests pockets of survival in North Africa's Mediterranean coast, East Africa's Rift Valley lakes, and possibly West Africa's Niger River delta. Each refuge developed its own survival strategies, its own innovations, its own path through the bottleneck. But the southern African coast was special. It had the most stable conditions, the richest marine resources, and the best caves. It's probably where the majority of the 1,280 survived, where the genes that would later populate the world were preserved. These weren't just hiding places. They were human laboratories where survival strategies were tested, refined, and perfected. The refugees that sheltered humanity also transformed it. In the bitter arithmetic of the bottleneck, selfishness equaled death. Not eventual death, immediate death. The 1,280 survived because they did something no previous human species had done at this level. They cooperated like their lives depended on it, because they did. Dr. Michael Tomasello, studying human cooperation, puts it starkly. The bottleneck created what I call obligate cooperation. You literally could not survive alone for even a day. Every human action required coordinated group effort. Consider a simple task: getting water. In the bottleneck, this required scouts to check for predators, guards to watch while others drank, carriers to transport water back, and defenders to protect the carriers. One person acting selfishly, drinking too long, abandoning guard duty, hoarding water, could doom everyone. The archaeological record shows unprecedented standardization during this period. Tools from sites hundreds of miles apart are virtually identical. Not similar, identical. This suggests information sharing on a scale previously unknown. Groups were teaching each other, copying successful strategies, sharing innovations immediately. Dr. Kim Hill, who studies modern hunter-gatherers, found echoes of bottleneck cooperation. These societies have one rule above all others: share or die. Not metaphorically, literally. Don't share food, you're exiled. Exile means death. The 1,280 developed what anthropologists call multi-level societies. Your immediate family was the first level. Your band of 20 to 50 was the second. Your regional network of 3 to 4 bands was the third. But here's the remarkable part: they maintained connections beyond that, with groups they might see once a year or less. Why maintain such distant connections? Risk distribution. If your area failed, drought, fire, predator invasion, you needed somewhere to go. These weak ties across vast distances were insurance policies written in social bonds. Dr. Robin Dunbar, famous for Dunbar's number, believes the bottleneck rewired human social cognition. Most primates can maintain relationships with about 50 individuals. The bottleneck pushed humans to 150 or more. This wasn't gradual evolution, it was rapid selection for those who could manage complex social networks. The evidence for hyper-cooperation is everywhere. Healed injuries that required months of care. Someone fed these people, protected them, carried them. Elderly individuals who lived years past physical usefulness. Groups that should have been desperate for resources still maintained non-productive members. One touching example, a child's skeleton from this period. showing severe developmental disabilities. This child lived to age 7, unable to walk, probably unable to speak. In a world where every calorie counted, a group spent 7 years caring for a child who could never contribute. That's not survival logic. That's love scaled to group level. The cooperation extended to information. Unlike other species that guard advantageous knowledge, the bottleneck humans shared everything. A better way to nap flint, a new water source, a novel hunting technique. These spread through populations like wildfire. Hoarding information meant your neighbors might die, and dead neighbors meant no one to help when you needed it. Dr. Sarah Hrdy calls this cooperative breeding, not just of children, but of ideas, innovations, and hope itself. Every human became parent to every child, teacher to every student, support for every individual. The group became a superorganism with one goal: survive. This cooperation wasn't soft or optional. It was enforced with absolute brutality. Modern hunter-gatherers still practice what the bottleneck created: mock the selfish, exile the greedy, and if necessary, eliminate those who threaten group cohesion. Cooperation was militarized. The bottleneck didn't just test human cooperation, it created it at a level that defines us still. Here's a mystery that haunted paleontologists for decades. Between 950,000 and 650,000 years ago, human fossils almost completely disappear from Africa and Eurasia. Where did everyone go? Now we know. They didn't go anywhere. There simply weren't enough humans to leave fossils. Dr. Chris Stringer from London's Natural History Museum explains the math. With only 1,280 breeding individuals scattered across Africa, the probability of any one of them dying in conditions that preserve fossils is essentially zero. It's like looking for a specific grain of sand in the Sahara. Fossil formation requires perfect conditions. A body must be quickly buried in sediment before scavengers destroy it. The sediment must have the right chemistry to mineralize bones. The location must remain undisturbed for hundreds of thousands of years. Then someone has to find it. In normal populations, thousands die every generation. A few get fossilized by pure chance. But with the bottleneck population, maybe 3 people died per year across all of Africa in the right conditions. Over 117,000 years, that might produce a few dozen fossils scattered across an entire continent. Dr. Bernard Wood, paleoanthropologist, calls it the inevitable gap. We're not missing fossils because we haven't looked hard enough. We're missing them because they were never there to begin with. But the gap tells us more than just about population size. The few fossils we do have from this period are all from the edges: Spain, China, Indonesia. These might represent populations that didn't go through the bottleneck or went through it less severely. The core population, the 1,280 in Africa, left almost no trace. The gap created scientific chaos for years. Some researchers proposed that humans abandoned Africa entirely. Others suggested a mass extinction followed by re-evolution. Theories got wild: underground populations, aquatic phases, even alien intervention was, briefly, considered by fringe theorists. Dr. Maria Martín Torres, studying the Spanish fossils from this period, noticed something telling. The European fossils from the gap period show signs of severe stress, malnutrition, disease, injuries. These weren't thriving populations. They were dying outposts of a dying species. The African gap is most telling. This is where humans evolved, where we should find the most fossils. Instead, nothing. The silence is deafening. It's negative evidence. Proof by absence. When fossils finally reappear around 600,000 years ago, they're different. Larger brains, more gracile features. signs of the coming speciation into Neanderthals, Denisovans, and Sapiens. The gap wasn't empty time. It was transformation time. The fossil gap also explains why human evolution seems to jump around this period. Before the gap, Homo erectus and early Heidelbergensis. After the gap, advanced Heidelbergensis heading toward modern species. The bottleneck was evolution's pressure cooker, and we only see the before and after, not the desperate middle. Dr. Tim White, veteran fossil hunter, admits the frustration. I've spent 40 years looking for fossils from this period. Every field season, we hope. But now we understand. We're looking for ghosts. The bottleneck humans were too few, too scattered, too careful to leave many bones behind. The gap that once puzzled us now confirms the bottleneck. The missing fossils aren't missing. They never existed. You can't fossilize what was barely there. The silence in the rock speaks louder than any skeleton could. It tells of a time when humanity was so scarce that we left no physical trace, only genetic echoes in the descendants who finally, miraculously, multiplied enough to rejoin the fossil record. Something extraordinary happened to the human brain during the bottleneck. It grew, not slightly, dramatically. While our ancestors were barely surviving, their brains were expanding at a rate unprecedented in primate evolution. Dr. Bernard Wood looks at the skull measurements and shakes his head. This shouldn't be possible. Brains are expensive tissues. They consume 20% of our calories. In a starving population, big brains should be selected against. Instead, they grew by 30%. The numbers are staggering. Homo erectus, entering the bottleneck, had brains averaging 950 cubic centimeters. The humans emerging from it had brains of 1,230 cubic centimeters. That's 280 cubic centimeters of growth during the worst resource crisis in human history. Why would evolution favor expensive brains when calories were desperately scarce? The answer reveals the bottleneck's cruel genius. Stupid died. Dr. Robin Dunbar explains, when survival requires remembering 100 water sources, 500 plant species, seasonal patterns, predator behaviors, and social relationships across multiple groups, a bigger brain isn't luxury, it's necessity. The bottleneck created what researchers call cognitive selection pressure. Every day presented problems that required intelligence to solve. Where to find food when regular sources failed. How to preserve fire in rain. How to track relationships in complex social networks. How to innovate when traditional solutions stopped working. The archaeological evidence supports this. Tool complexity increases during the bottleneck, not gradually, exponentially. Simple hand axes give way to composite tools requiring multi-step planning. Fire use goes from opportunistic to engineered. Hunting strategies shift from encounter to ambush, requiring theory of mind to predict prey behavior. Dr. Chet Sherwood, studying brain evolution, found something remarkable. The growth wasn't uniform. Areas associated with planning, social cognition, and language expanded most. The bottleneck was literally sculpting brains for the challenges it presented. But how could starving humans afford bigger brains? The answer is cooking. Fire-processed food releases 30 to 50% more calories. Cooking breaks down proteins, gelatinizes starches, neutralizes toxins. The same amount of food suddenly provided more energy. That extra energy went straight to brain growth. There's another factor, the expensive tissue hypothesis. As brains grew, guts shrank. Cooking meant less intestine was needed for digestion. The energy saved from maintaining smaller guts was redirected to bigger brains. Evolution was reallocating resources from digestion to cognition. The social brain hypothesis also kicked into overdrive. In groups of 30 to 40, Everyone knew everything about everyone. But maintaining connections across multiple groups, tracking distant relationships, managing complex social politics, this required unprecedented social intelligence. Dr. Alison Brooks, studying cognitive evolution, notes, the bottleneck created a feedback loop. Smarter individuals survived better, had more offspring, selected for even smarter mates. Intelligence became the primary selection criteria. The growth had costs. Bigger brains meant longer childhoods, more time for brains to develop. Longer childhoods meant extended dependency. Extended dependency meant groups had to cooperate even more to raise children. It all interconnected. By the bottleneck's end, human brains had crossed a threshold. They were large enough for true language, abstract thought, and symbolic reasoning. The humans emerging from the crisis weren't just survivors, they were cognitively modern. The bottleneck that should have made us simpler made us smarter. Pressure that should have reduced our brains expanded them. A crisis that should have stripped away complexity added it. Every thought you think happens in a brain that grew because thinking meant surviving. 813,000 years ago, something changed. The grinding ice ages began to ease. Rainfall returned to Africa. Plants that hadn't grown for millennia began sprouting, and the 1,280 began to multiply. The recovery wasn't gradual, it was explosive. Within perhaps 1,000 years, the population increased 20-fold, from 1,280 to 26,000. Within 10,000 years, hundreds of thousands. The humans who had barely existed suddenly existed everywhere. Dr. Yi Xuan Pan, who helped discover the bottleneck, describes it. The genetic signals show simultaneous population expansion across all African groups. Like someone flipped a switch and humanity turned back on. But this wasn't the same humanity that had entered the bottleneck. 117,000 years of selection pressure had fundamentally changed them. They were smarter, more cooperative, more innovative. They had survived the unsurvivable and emerged transformed. The first sign of recovery appears in the archaeological record as a sudden proliferation of sites. Areas abandoned for over 100,000 years show human occupation again. Tools appear in new regions. Fire hearths multiply. It's like watching a time-lapse of flowers blooming after rain. The expansion wasn't random. Groups followed specific strategies learned during the bottleneck. They stayed near water sources but maintained multiple camps. They kept trade networks even when resources were plentiful. They continued the hyper-cooperation that had saved them. Dr. Chris Stringer notes, they didn't forget the lessons of near extinction. The behaviors that saved them became cultural traditions. Sharing, cooperation, innovation, these weren't abandoned when times improved. They were institutionalized. The tools tell the story. Acheulean hand axes, unchanged for 1,000,000 years, suddenly show variations. Regional styles emerge. Groups are innovating, experimenting, no longer locked in survival mode. The cognitive abilities developed during the bottleneck were being unleashed. Population genetics reveals 3 distinct expansions. One group stayed in Africa, spreading across the continent. Another moved north into Europe. A third headed east into Asia. The bottleneck population was splitting into what would become Homo sapiens, Neanderthals, and Denisovans, but they maintained connections. Genetic evidence shows gene flow between populations continued for thousands of years. The networks built during the bottleneck persisted, even as groups spread across continents. The 1,280 had learned that isolation meant death. The recovery accelerated innovation. Fire use became universal. New tool technologies emerged. Hunting strategies diversified. For the first time, humans began modifying their environments rather than just adapting to them. Controlled burning to encourage certain plants. dam building to trap fish. Humanity was taking control. Dr. John Hawkes, studying this period, observes, "The recovery wasn't just demographic, it was cultural, technological, cognitive. The bottleneck had compressed human evolution like a spring. The recovery was the release." By 700,000 years ago, humans had not just recovered, but exceeded pre-bottleneck populations. They occupied more territories, exploited more resources, showed more cultural complexity. The near extinction had somehow made them stronger. The recovery also saw the first signs of what would later become art. Scratched patterns on bones, collected crystals with no utilitarian purpose, ochre use beyond simple preservation. The humans emerging from the bottleneck had mental space for beauty. The long recovery proved that the bottleneck hadn't weakened humanity, it had refined it. Like steel forged in fire, the species that emerged was harder, sharper, more resilient. Around 800,000 years ago, as the bottleneck ended, something unprecedented happened. The surviving human population split three ways, creating the three most successful human species in history: Homo sapiens, Neanderthals, and Denisovans. Dr. Svante Pääbo, who sequenced the Neanderthal genome, explains, "They all carried the signature of the bottleneck, the fused chromosome, the reduced diversity. They were sibling species, born from the same near extinction." The split wasn't immediate or clean. For thousands of years, the populations remained similar, occasionally interbreeding, but geography and adaptation gradually pulled them apart. The group that stayed in Africa faced continued climate instability. The continent's weather remained unpredictable, selecting for flexibility and innovation. These would become Homo sapiens, the adaptable generalists. Their survival strategy was to have no fixed strategy, to change with circumstances. Dr. Chris Stringer notes, "Sapiens were shaped by chaos. Every generation faced different challenges. This created minds that could imagine different futures, plan for uncertainty, innovate constantly. The population that moved into Europe encountered a different world. Reliable ice ages, predictable seasonal patterns, abundant large game. They adapted by becoming specialists. Massive muscles for close combat hunting, large nasal cavities for warming air, compact bodies for conserving heat. They became Neanderthals. Their brains grew even larger than sapiens, reaching 1,500 cubic centimeters. But the growth focused on different areas: visual processing, spatial memory, or sensory integration. They became the ultimate Ice Age predators, perfectly adapted to their environment. The eastern population spreading across Asia became the mysterious Denisovans. We know them mainly from DNA, but that DNA tells an amazing story. They adapted to everything: high altitudes in Tibet, tropical rainforests in Southeast Asia, perhaps even island life in Indonesia. Dr. Murray Cox, studying Denisovan genetics, discovered they were the ultimate adapters. Different populations evolved different capabilities. High altitude genes here, disease resistance there. They were like three species in one. All three inherited the bottleneck's gifts: enhanced cooperation, sophisticated tool use, controlled fire, complex communication. But each developed these differently. Neanderthals created the first confirmed art, the first burial practices, the first musical instruments. Their societies were small but intensely bonded. They cared for injured members for years. They were humanity's heart. Denisovans developed technologies we're only beginning to discover: possible boats, definite jewelry, probable trade networks spanning thousands of miles. They were humanity's reach. Sapiens developed something else: the ability to believe in things that didn't exist, Gods, spirits, stories, futures that hadn't happened yet. This capacity for fiction allowed them to organize in groups larger than family bonds could sustain. They were humanity's imagination. For 50,000 years, Earth had 3 human species, each magnificent in its own way. They occasionally met, occasionally mated, occasionally competed. The planet was more humanly diverse than ever before or since. But only one would survive to the present. The very traits that made Neanderthals and Denisovans successful, specialization and regional adaptation, made them vulnerable to rapid change. When climate shifted quickly around 40,000 years ago, the specialists struggled. Sapiens, the chaotic generalists, thrived on change. They absorbed beneficial genes from their cousins through interbreeding, then outlasted them through sheer adaptability. Today, we carry 2 to 6% Neanderthal and Denisovan DNA. We are not just the descendants of the bottleneck, we are the fusion of its 3 outcomes. Every human alive is part sapiens, part Neanderthal, part Denisovan. The bottleneck created 3 masterpieces. We are the combined gallery. Look in the mirror. The face staring back carries invisible scars from the bottleneck, genetic wounds that still affect your health, your thinking, your very survival 900,000 years later. Dr. Joshua Akey, population geneticist, doesn't sugarcoat it. We're a genetically damaged species. The bottleneck left us vulnerable in ways that would have doomed any other mammal. We survive despite our genetics, not because of them. The most obvious scar is our pathetic genetic diversity. Chimpanzees from a single forest have more genetic variation than all humans across all continents. We're so genetically similar that alien geneticists would classify us as critically endangered. This lack of diversity makes us sitting ducks for diseases. A pathogen that can infect one human can potentially infect all humans. We lack the genetic variation that protects other species. COVID-19 spread globally because we're basically genetic clones compared to other mammals. Dr. Sarah Tishkoff, studying human genetics, found specific vulnerabilities. Certain genetic diseases are common in humans but rare in other primates. Sickle cell anemia, cystic fibrosis, Tay-Sachs, these persist because the bottleneck reduced our ability to purge harmful mutations. The bottleneck created what geneticists call founder effects. Rare mutations in the 1,280 became common in their descendants. A mutation that might have affected 1 in a million pre-bottleneck humans now affects 1 in thousands. Our immune systems are particularly scarred. The 1,280 survivors carried limited immune diversity. We lost countless immune variants that had evolved over millions of years. Modern humans are essentially immunocompromised compared to our pre-bottleneck ancestors. Mental health vulnerabilities trace to the bottleneck too. Anxiety disorders affect 30% of humans but are virtually unknown in other primates. The hypervigilance that kept the 1,280 alive now manifests as generalized anxiety in safe, modern environments. Depression rates in humans dwarf those in other mammals. The deep social bonding necessary for bottleneck survival created brains that malfunction in isolation. We're literally wired for connection at a level that becomes pathological when unmet. Dr. David Reich, studying ancient DNA, found something disturbing. Harmful mutations that should have been selected against were preserved because the population was too small for selection to work efficiently. We carry genetic debt from the bottleneck. But the scars aren't all negative. Some damage became advantages. The fused chromosome that could have been catastrophic became part of what makes us human. Mutations that cause problems in one environment provided benefits in others. The bottleneck's genetic homogenization had an unexpected benefit. It made us universal organ donors within our species. Other primates can't easily share organs even within their species. Humans can transplant hearts across continents. Our genetic similarity enabled civilization. We can communicate across populations because our brains are wired similarly. We can form societies of millions because we recognize all humans as fundamentally us at a genetic level. Dr. Spencer Wells, geneticist and anthropologist, puts it philosophically, "The bottleneck made us genetically weak, but socially strong. We compensate for genetic vulnerability through cultural and technological innovation. Our scars forced us to become something more than biological. The most profound scar might be psychological. Deep in our genes, we remember near extinction. Our hoarding instincts, our fear of isolation, our desperate need for community, these are genetic memories of when such things meant survival. Every human alive carries these scars. They're in your DNA, your brain structure, your disease vulnerabilities, your psychological needs. You can't escape them because they are you. The bottleneck didn't just test humanity, it marked us forever. We're walking wounded from a war we won 900,000 years ago. Imagine Earth without humans. No cities, no art, no music. Whales sing in oceans without ships. Forests grow without axes. The planet spins through space, teeming with life, but no consciousness capable of knowing it spins. This almost happened. For 117,000 years, we were one drought, one disease, one predator attack away from this alternate Earth. The margin between our existence and our absence was 1,280 breeding individuals. Dr. Chris Stringer contemplates the near miss. Statistically, we shouldn't exist. The bottleneck lasted too long, the population was too small, the challenges too severe. Our existence is the ultimate lottery win. What would Earth look like if those 1,280 had died? Neanderthals might have persisted longer without sapiens competition, but climate change would likely have finished them. Denisovans might have dominated Asia, but their specialization would have limited global spread. Or perhaps another ape would have eventually evolved consciousness in another million years, or 10 million, or never. The planet would be radically different. No human-caused extinctions. Mammoths might still roam Siberia, giant ground sloths in the Americas. No deforestation, the Amazon would stretch unbroken, the Sahara might still be green. No climate change, at least not the anthropogenic kind. Would Earth be better without us? That's the wrong question. Earth doesn't care. But consciousness would be absent. The universe would exist without any part of it knowing it exists. Beauty would occur without observers. Questions would never be asked, let alone answered. Dr. Carl Sagan once said, "We are the universe's way of knowing itself." The bottleneck almost prevented that knowing. But what did we learn from almost not existing? First, that existence itself is precarious. We're not inevitable, not chosen, not destined. We're lucky. Every generation since the bottleneck has been borrowed time. Second, that cooperation isn't optional for humans. The 1,280 survived through unprecedented cooperation. When we abandon cooperation for competition, we're betraying the very trait that saved us. Third, that adaptation is our superpower. The bottleneck survivors didn't just endure change, they embraced it, learned from it, were transformed by it. Rigidity would have meant extinction. Fourth, that diversity matters. The bottleneck's reduction of genetic diversity still weakens us. When we reduce diversity, genetic, cultural, intellectual, we're recreating bottleneck vulnerabilities. Dr. Spencer Wells reflects on modern implications. We're creating new bottlenecks. Climate change, nuclear weapons, pandemics. Any could reduce humanity to desperate thousands again. The difference is, this time, it would be self-inflicted. But perhaps the most profound lesson is about resilience. The 1,280 faced challenges that would break most species. They were genetically compromised, environmentally stressed, demographically doomed. They survived anyway. When modern humans face seemingly insurmountable challenges, climate change, inequality, conflict, we carry the genes of those who faced worse and won. Not through strength or intelligence alone, but through cooperation, innovation, and sheer refusal to surrender. The bottleneck gave us a gift, the knowledge that we almost weren't. Every human birth is a victory over ancient extinction. Every day our species continues is a defiance of odds that should have killed us. Dr. Yi Xuan Pan, whose research revealed the bottleneck, offers a final thought. Knowing how close we came to never existing should change how we see existence. We're not separate from nature or above it. We're nature's most improbable experiment, consciousness that almost never was, looking at a universe that almost never knew itself. The 1,280 didn't know they were saving consciousness itself. They just knew they wanted to live. They wanted their children to live. They wanted their small bands to see another sunrise. 900,000 years later, 8 billion humans watch sunrises they made possible. Every one of us exists because 1,280 people refused to become nothing. What almost wasn't, is. And knowing that changes everything.